Hello all. Today we are going to talk about optional SwiftUI view. This is a syntactical sugar in order to replace optional binding within SwiftUI. The universal freedom to come up with a solution is always with an individual. The intent of this video is to share perspective and look at an approach to handle optional data within SwiftUI. Let's deep dive into the code. We'll start with already written code where we have a content view which has a view model and it has a single function that returns an optional card view model. Right now it has a hard-coded value, and once we run the application, you'll be able to see the card. If you return a nil, the and run the application, we'll be able to see the no cards available. Now let's undo the changes and look into the code. So it is an if condition where if it is optional, we have returned a card view, and if it is not, we are returning the text. And this is what a typical optional binding in SwiftUI view would look like. Now let's create a SwiftUI view and name it optional view. We'll add two generic parameters, content and data. Content is of the type view, and now we will define two variables of the data as well as content type. Content would be a closure which has data as the signature and returns the content type. Just to clarify here, the small letter content is used as the member variable and the capital letter is the generic type. Now in the body, we will implement the if let conditional binding, and if the data is non-null, we'll call the closure with the data as input, and in the else case, we'll return empty view. We'll add the initializer also, which takes in data and content. Now let's correct the compilation error in the preview in order to have the canvas preview enabled. There is an error. Okay. Oh, so we juggled the optional, sorry, the generic type. Now that we have corrected, it should work fine. Now let's comment the existing and let's replace it with optional view. The data would be view model and view model dot card model, which returns an optional value, and the closure parameter would have the data which is now passed into the card view. Now you can see the simulator having the card view, and once we return nil, it's empty. It doesn't show the error view as previously. And the reason for this is null state not being implemented. Let's try to implement the null state. Okay, so in order to implement null state, we'll go to the optional view and we will replace the empty view with what is required to be shown when the data is non-null, and we get to show that. But the question is this the scalable solution? Because we are hard coding, or rather we are making the null state very specific. We want somehow a means to inject null state. We'll take an approach where we define generic error state, empty state, or let's call it null state, right? The null state generic parameter also is of the type view, and we define a closure that returns null state. Now we would call that closure inside the null state, And what happens here is that, okay, we have to make it optional because there might be cases where we would want to show empty view, right? We don't want to show any null state. So if null state closure is passed, we'll call the closure, else we have empty view. Let's add the parameter to the initializer as well. Okay, now we have corrected all the signature and we pass the null state from the content view. Let's try to run. Okay, there is an error. In the preview, we have to correct it. Okay, I think preview is not required. We'll make the null state. Okay, we didn't make this as option. Right now, we'll make the null state as option and we'll try to remove it. Still error. Okay, I think we have not given default value. Okay, the trailing closure syntax is not correct. We'll make constructor pass the default value as null. Okay, escaping is not required for option. Now it is solved. We are able to run the application, and in case of null, it shows the no cards available text. This approach is not very clean, right? We will look into a better approach where we use custom view modifier. It's more from a readability perspective, where we are now going to remove the parameterized null state version into a view modifier. Let's go to optional view. In the optional view, we have used null state. Now we are going to write an extension where optional view has a method which is setup. It takes null state closure as the signature. Let's copy paste. And yeah, let's correct the escaping part. What it does is that it creates a copy of the current optional view and it actually mutates the null state to the null state variable passed along with this function and it returns the optional view. So this is typical declarative style of functional programming where you create an object. Okay. Yeah, rather than mutating, I think we'll use the mutable copy and return the mutable copy, right? So we'll also define the return type as self. Once this is done, now we can remove the constructor null state parameter and we can initialize that as null. I mean, obviously we can keep it as well, but the point is we are demoing the view modifier. Now the same syntax would become using a view modifier setup where you pass in the null state and that's it. So this looks more organized and cleaner compared to parameterized. And it follows the functional programming thought process of mutating the object and the null status, setup. Let's run the application and we can see the empty view. Let's return the card view model as well and run it again, we'll be able to see the card view. The intent of this video was to introduce the concept of optional view to replace optional binding. With that being said, one might see certain patterns that which is not ideal for production ready app. This has been used as a temporary code to demo the concept of optional view, and it is advised not to use this in production ready app. The slide gives an overview of some of such instances. Before we end, let's look into initializing optional view without a null state. The code that we previously wrote had the setup method in it. Now let's write optional view with the same view model and the card view, and the parameters which are generic is now read with type inference, and we have actually used the underscore, and the setup view, or sorry, the null state is empty view. If we run the application, we will be able to see the empty view, and once we comment the null and we run the application, we will be able to see the card as well. With that, we are at the end of this video. Thanks for watching.